In this video, we're going to be finding the inverse of a function that has a restricted domain. Let's talk a little bit about why it might be restricting the domain. It's not always the case, but sometimes. So a function f with an implied domain of all real numbers might not necessarily pass the horizontal line test, meaning it would not have an inverse function. So in this case, the domain of f may be restricted, so the f does have an inverse function. So f of x equals x squared is not one-to-one. So let's take a look at that. So we have our equation, and if we type in x squared, and then we graph that, if we did the horizontal line test there, that would not pass the horizontal line test. It would clearly touch our graph in two spots. So by restricting the domain of f to x has to be greater than or equal to 0, the function is now one-to-one, and it does have an inverse. So let's talk about how exactly we work that out. It really kind of just follows those simple steps we had before, where we're going to rewrite it as a y equals, then we're going to switch the x with the y, and then we're going to solve for y. So here we'll just take the square root of both sides, and that's going to give us that y equals the square root of x. But here, up here, we need to say that y has to be greater than or equal to 0, because when we switched that, our domain of f became the range of f of x, or y. So we need to have that restriction there. Which is why here our answer is just y equals the square root of x, because y has to be greater than or equal to 0 in order to take that square root. So we're able to write, as we rewrite it, that the inverse function of x is simply just the positive square root of x. And we can verify this by finding our f of inverse f of x, and by finding our inverse f of x of f of x. I said that kind of weird. Our inverse of f of x. So here we'll take our f, which is x squared, and we plug in our inverse, and we see those go away, and that leaves us with an x, which is what we want. And then we check our other ones. We take our inverse, which is the square root of x, and we plug in our f of x, which is x squared, and we know that a square root and a square undo each other, giving us an x, which again is what we want. So we've verified now that this is in fact the f of x's inverse. So that's why we might have a restricted domain for functions.